plus.
Okay, so I'm going to try one of these interview practice problems this time. I also moved the webcam recording into the top right so to get less in the way of you guys potentially reading the problem. These guys are trickier, so might not be as awesome. And unfortunately, I've already done all the array questions. Um, where do I want to be? We'll just continue on the linked list stuff, I guess. Is List Palindrome. Yeah, let's give this a go. All right. Oven time using no additional space, called constant additional space. N is the number of elements, and all right, cool. So that's like, don't be silly. Um, this list palindrome. The output should be if the palindrome is false. Okay, so we're gonna need to do an in-place reverse. Is the thing, right? Yeah. So we're gonna need to do an in-place reverse of one of the halves of the list. Doesn't really matter which half we pick. We just got to reverse one of them. And then we'll do a comparison. Then we'll check whether the lists are the first half and the second half are they identical. And then we'll be done. I wonder if it cares if I blow up the original list. Because that's what I'm gonna do. I don't think it cares if I blow up the original list. Frankly, the only option I have, I think, is to blow up the original list because there's no way to keep it in O of one space without constant extra space without blowing up the list. And even saving a way to recreate, I can do another in-place reverse, right? Yeah. I'm just gonna blow it up though and leave it messed up. And if they don't have a problem with it, it's fine. If they do have a problem with it, I can just call my in-place reverse deal again, and that'll fix it. So I think the simplest way to organize this is going to be to have a function that does an in-place reverse for us on a list. And we'll figure out what list we should put in here at some point. So then to do an in-place reverse, we have we're just going to get a node, and we want the next node's next to point to us, and our next to point to end. So we're going to start with L. And we're going to store the next node is L dot next. And then when we do the in-place reverse, this first node that we get is now the last node. So L dot next is now none. And then while the next node is a thing, so if the next node was none, we're done reversing already. And if it's not a none, then So then the next node our temp next node is L dot is next node dot next, and then now we can mess with the next node, right? So now next node is we're going to need a current node. Our current node is L. And then if our current node is L, next node so our current node is L. We change the first its next we save its next node, and the next node is none for L. And then while there is a next node attached to L, yeah, so this might be cleaner. If we just pass it a previous node, we can do this recursively, right? So if we're reversing a list, and where this is the first thing we reverse, we just pass it none for the previous node. So then our L dot next is going to be previous node. So the L dot next is, so next node is L dot next. We don't need this loop anymore. So L dot next is the previous node. So we're doing in-place reverse of L dot next with L, right? So that'll reverse the rest of the list. And then we need our base case now. So if L dot next equals none, then we just say the next node is now the previous node, and then otherwise we're going to do this in-place reverse on the next node. And then once we're done with the in-place reverse of the rest of it, we attach our next becomes the previous node. And then if we just call this with none for the first reverse. Okay, so that's our in-place reverse. All right, I'm going to stop and restart the recording. Okay, we are continuing. I just watched my own video for a couple seconds there. I do like the webcam being in the top right. Hopefully I remember to stick with that. And let's continue. So I think this in-place reverse is going to work. So let's go ahead and just proceed And if it seems like it's not working, then I'll go back and try to fix it. So there's our in place reverse. We also need to count the number of things in the list. That's super simple. So we're going to take a list and find the length of the list. If it's none, or it's 0, otherwise, then length is 1, and while L dot next is a thing, current node is L, and while current node dot next is a thing, then actually we could have just used L, whatever. So while current node dot next is a thing, length is 1 more, and then current node is equal to current node dot next, and that'll loop us through the thing, and then we just return the length. Okay, so now I can find out the length of the list, and I can do an in-place reverse of a list. So anything else I need? So the length is equal to the len list of L. I really don't like using L, but I should have switched that right away. So I guess I'm just going to roll with it. So, because L's look like ones. So the length of the list of L is length. And then we want to go to the middle spot, and we are going to want to have the previous node and the next node. Actually, we're going to want to be able to compare two lists too. So so we're going to need to compare two lists. So we're going to say while equal. So we're going to set a Boolean equal is true, and while they're equal, if so current node 1 is list 1, and current node 2 is list 2, and if the current node 1 dot value is equal to the current node 2 dot value. If it's not equal, actually, is when we want to do something. We just return false. And then if they are equal, current node 1 is current node 1 dot next, and current node 2 is current node 2 dot next. All right, so now that tells us if they're equal. So they could both be none. We have to handle that. Because it's not going to, it's going to tell us there's no value attribute of a none. So if they're both none, we're not going to get there to them both being none unless we're there. So we can just return true. And there's probably a better way to lay this out, but if they're both none, we return true. Then if one or the other is none, so if not, so this is an else if actually. That's right. If that's a none or the other one's a none, we return true if they were both nuns. Now we return false, right? I'm actually not, I don't need to actually handle this because I'm always going to run them with things of the same length. But so cur node 1, cur node 2. So if either of them are nuns, we return false. If their values don't equal, we return false. So now we need to worry about, this should be in an else. And then that's also in the else. All right, so if they're both none, we return true. If they're not, if one or the other is none, we return false. Otherwise, we return false. And we never set, this is, I don't like doing this, but, and then we're always going to hit a return. Yeah. So now we can get the lists are being equal to. So we figure out the length of the list, and then we need to be able to go to a location in a list as well. So we're going to be able to go to a location in a list now. We're just going to assume that you don't do this stupid and the location is in the list. So there's our list and there's our location for. All right, we're going to restart the recording. All right, and we roll on. So we're going to want to be able to go to a location. So here, if we're going to a location in the list, we have our location. So for I in, actually we don't need I, for whatever in range location, and we're assuming the location's in the list. Cur node is wherever we are right now, and then cur node is equal to the current node next, and then we would just return the current node. So that should get us to the right spot. So if range 0 gets us, we just return the list itself. All right, awesome. So now we can go to a location. We can check whether lists are equal. We can find the length of a list. We can do an in-place reverse. All right. Actually, this would be easier for me because I'm going to need the previous node to do my reverse. So it would be better if I returned a tuple here. So, all right, previous node is equal to we'll think about whether I need to do that later. So we find the length of the list, and then we say we need to decide what the back half is and what the front half is. And we should, this should go have a length because the back, yeah, it's all, yeah, this is not what I want to be doing. So we need a length here. So then this, we can just assume that our length is valid. So this will simplify this dramatically. So then for, doesn't matter what it is, in range length, if the node value is not equal, return false. Otherwise, we go one node further. Then we check again. And then if we make it out of the loop, we return true. Okay. I wish I had realized that right away. All right. So now we need to figure out what our back end is. So if the length of list is 5, the two things we want to compare are the last 2 items reversed with the first 2 items. So we want to go to which location then? 0 is would give us the first item, and we want to go the middle. If we divided our 5 by 2, we would get 2 when we integer divide. And we want to go to the net one item past that. What if it's an even number? Say it's 4 is our length. We divide by 2, we get 2 again. And we want to stay at the second item. It's the back half. 0, 1, 2, yeah. And then for 5, it's 0, 1, 2. We don't want to touch the second item. Okay. So, start. So, the length of our check. So, len of our check is the length divided by integer divided by 2. So for 5, our length of our check is 2. For 4, the length of the check is also 2. For 3, the length of the check is 1. All right, yep, that makes sense. And then where we want to go, we want to go to the end minus the length of our check. So 4 minus 2 puts us at index 2, which is where we want to be. And then 5 minus 2 again puts us at index 3, which is also where we want to be. Yeah. So the back half is 0 to location L and length minus length of our check. And that gives us the back half of the list. So now we want to do an in-place reverse. So before we are going to make this return a tuple. Because to do my in-place reverse, I'm going to want to have whatever the previous node is. So to go to a location, now we need a previous node. That's going to start out as none, right? And then every time we're here, our previous node is equal to our current node. And then current node. And next, yep. And then we're going to return previous node there. And then that will go here. And then we're going to do our in-place reverse. So the our in-place reverse, we say L in-place reverse. We're going to pass it the back half, and then we want to reverse we have to pass it the previous node. All right, so the previous node here is before back half. So that does our in-place reverse. Now we need to check that they're equal. So here, list one, list two length. So, and we can just return it. So return list equal. All right, and then we'll say L back half, and then we can give it the length, which is len check. And that should get it done. Obviously, I've blown up the list. I could easily do another in-place reverse on. I could just repeat this line of code, and that would fix it. And I would do the check, store that, reverse it back. But I don't think they're going to care, so I'm not going to bother. I wrote a lot of code here and didn't run anything, so I'm suspecting this is going to have errors. Yeah. Oh, yeah, I did some goofball stuff. Where was that? Line 9. So we'll put the not there, and then we're going to restart the recorder, hopefully for the final time. Okay, so we're rolling on. I just fixed that first syntax error. So we're going to go ahead and run the test again, probably get more syntax errors. Yep. None type has no attribute. Next on line 9. All right. So if it's a none, what do we do? I have to think about this. So if we have if it's a none, which means we've passed this in, we've got a previous node, which should already be, I think we just do nothing. Yeah. So that's goofball. We don't need to write it like this. So we should say if L dot next, and then we do the in place reverse. And then eventually we'll hit a case where there's L is not. So then here we just return, right? We don't need to do anything. And then okay. I think that works. Not super confident. Let me think. So then when we hit the last node, we just don't do anything. And then we're not going to, I think that works. All right, let's see what's going on now. None type has no attribute. Next, what line are we on? Is Palindrome, line 46. On line 9, none has no attribute. Next. What was my original code? Oh, so this should be if L. Yeah, I think that does it. Oh, and then if L is a thing, then we do the in place reverse. And if L is not a thing, yeah, okay, I think that does it. Okay, so now we're actually passing some tests now. I expect to have more issues than that. We are failing some tests though, so we're only failing. We're passing most. We do have an issue here. We'll have to investigate any commonalities between the ones we pass and fail. First, let's look at the one we fail. My expected output is true, and I say it's not a palindrome. So here, 1, 2, 3, 4, 5. There's 6 things. So the first thing I'm going to do is I'm going to print out our what we're getting for the length. And then we're also going to print the length of the check. And then let's just see what those are first, and then we'll continue trying to find other issues. So the length is 6, length check is 3. That makes sense, right? Yep, it was 6 long, length check is 3. I buy that. I'm liking that. We'll get rid of the extraneous output later. We can leave it for now. All right. L back half len check. So our first value, let's print out the value of back half. Make sure back half is where I think it is. So print first val in back before reverse, and that's going to be back half dot value, and then we'll print the first val in back after the reverse, and that's again back half dot value. Syntax error in what I just wrote. What? So I what? So we don't have values where we would expect some values to be. But how the heck does my code work on some cases then? So I'm thinking it's an odd even thing. So yeah, that's an odd number. This is, that's an even number. Oh, but I see I'm outputting false. So that's fine. And then when we get true for an odd number correctly, but we're going to get false for all the evens, I bet, which is why we're failing these cases. Yeah. So our problem, I bet, is in the reversing with even numbered lists. We've got something wacky going on. So our in place reverse, we start our bat at go to the location length thus length minus the length of our check. So for our case with the 6, right, the length of our check is 3. So we're going to the third spot, 0, 1, 2, 3. Yep. And that wait a second. Let's go look at our output again. All right. I actually am going to take a bathroom break. I'll be right back. Okay, restarting after that bathroom break. So here I was wondering, because this should be giving us the back half after that go to. So it should have a value. All right. Yeah. Gotcha. So when we run this failing case, the first val in back after the reverse did not reverse. Right? This works. How does that work? Oh, because it's not supposed. Yeah, so they always get false. Yeah, so I mentioned that. I think it always fails for those cases. And then let's see some of the other cases we're passing. So here, okay. I don't think this is reversing the way I want it to. I think we passed this case by luck. Yeah, because there's nothing to reverse. And this case, we pass because we're failing. We tell them they're all false. And then we fail all of these. So it actually is not an even odd thing. It's the reverse is not Yep, I have to handle that. We'll worry about that test case later. Why am I not even getting to those test cases? I don't know. All right. So anyway, the reverse is not reversing. At least not the way I expect. So if we have a list, so if there is a thing in there, we do an in-place reversed on the next node with us as the previous node. Otherwise, we just return. And then we say my next value is equal to the previous node. So this is I'm now pointing to the previous node, and the next one Yeah, so we've got an issue here because we're not. So I'm drawing a picture on the side here. So here I'm saying I point to the previous node. My next is the previous node, but I never update the previous node's next, right? Yeah, I never update the previous node's next. Um, and then so if I started my reverse at a spot, the next node after that points back, and then when we get to the one that points to nothing, it doesn't do anything. Well, if I am nothing, it doesn't do anything. If I'm pointing to nothing, then I say my next points to my next end up pointing to the previous node. Yeah. So our problem is we reversed all the pointers, but we're not in the right spot anymore. Well, we're just return. Yeah. So we need to end up with So eventually the previous node's next value needs to become whatever the last node was. And because you're going to point to, so you should point to you. Huh. I need to think more about this in place reverse. So I'm starting here. And what I should end up with is A, B, C. So I'm doing it with 5. And what I need to end up with is, so I need to end up with A goes to B, goes to C, which goes to E, which then goes to D. That's what I want. So C needs to point to E now. And then D. So the first point, whatever we start with, its next has to become none, actually. So this is wrong, I think. I think I'm just going to blow this function up and try again. So, L dot next is none. So whatever we pass this to becomes the last node, or wherever we start with becomes the last node. So it's eventually going to have its next value be none. But we're going to store it somewhere before we do that. And then say my next node was none, then I don't have anything to reverse, right? So we'll say if L dot next, if not L dot next, is return. I have to return something eventually. So if our next thing is nothing, we're done. that means we've got past a list of one item that we're reversing, and there's nothing to do. Otherwise, our next node becomes none, and the next thing should then point to us. So while there is a next node, then the next node should point to us, right? So we'll call it our current node is our spot. All right, I'm going to restart again. Okay, so here we go. Restarting after the recording length ran out. So if L next return, all right, so our current node is L. And then while there is a next node, next, now that needs to point to the current node, and then we need to store it. So temp next node equals next node dot next. Okay, so the next node, might be a wacky thing. So if there is a next node, it needs to point back at us, and then the current node becomes the next node, and the next node becomes the temp next node. Okay, and that I think that does our reversing. And I think that does it. So let's go back to my picture that you can't see. A, B, C. So if there's not now dot next, we return, so that we fail that case. Next node is L dot next. Okay. Current node is L. This is now pointing to nothing. And then the next node is next node so then we store this next node, temp next node next. All right, so that's going to be the nothing. Next node dot next now points to our current node, so the E does now point back to the D, and now we're on the E, and the next node is the temp next node. Okay, so now I think our only problem is that we never connect back the original previous node to what we end up with, which is not that big of a problem. So here we want to say previous node next is now equal to the current node. And that should get it done. Okay, and then, so if that works I think it does work. Then the rest of the things, so now our problem is that when we mess with the list, right, now our current node is the back, right? So we need to do another go-to, right? So before back half is go to location. And then we do the in place reverse. And then we need to get the location of the back half again. So, so this time we don't need the tuple. So we'll just underscore comma back half is, we're going to the same spot now. And then we can check that they're equal. Okay, so that might have fixed it. I might have created more syntax errors now. Yep. None type has no attribute value on test 6. So once again, we're passing some tests. So let's look at the tests we're passing, see if our output looks reasonable. So yeah, that one's not super interesting. I actually want to print the value after the reverse as well. That'll help me. So we'll give that a go. Oh, no, that's not the spot to put that. So I think you should be here. Yeah. So we're still having the same error, but if we look now, our output on the test cases we are passing should be more useful to us. So first val and back, before reverse, after reverse is a 3. Okay. That's the empty list case, is the one we fail. What is the next one we fail? I think it might just go to the first test case you fail. My console output's nothing, right? There's no way I should have nothing for console output. Because it's the first thing it does is takes the length of the list. So let's handle that empty case right away. So if length is 0, we just return true. And that's should handle test 6. All right, so now we're on test 9. So yeah, it does look like here that if you fail a test, then you don't necessarily run the next test. Yeah, so we're on test 9 now. One item. Yeah, that is also a tricky case. And it's always a palindrome. So we can just avoid it. Okay, so that passes them all now. That was a pretty tricky little problem. It'd be much easier if you didn't have to, if without this no additional space usage thing. If you use additional space, it's way easier. How happy am I with my answer? Well, that's okay. Again, it's okay. There's definitely room for improvement here, though. This second go-to location is not something we should have to do. I should just get the location when we do the in-place reverse somehow, and that would say you wouldn't have to go run through the list again. It's still O(n) time though, because I can do as many runs through the list as I want, as long as it's some sort of constant number of runs through the list. Yeah. Okay, so I'm gonna run their real tests in a last video, and then we'll look at some other solutions. Okay, so yeah, we were just talking about how we're gonna run their submit test cases. They tend to be more pathological, and there's been times where I've gotten timeouts because I haven't done something super efficiently. For some cases, actually in arcade mode, this happened to me a lot of times when I do something with recursion. But I think we'll just go ahead and hit submit, see what happens. No point in solving problems that don't exist yet. Okay, cool. Solved. I always like to look at other people's answers once I solve the problems. See what else is out there. Okay, so this guy cheated. He totally ignored the constant additional space requirement, which obviously makes the problem way less complicated. Yeah, this is garbage. Yeah, he makes a copy of the entire thing in a Python list instead of a linked list. And then it's like ridiculously simple. Well, duh. Again, does anyone actually solve the problem? Okay, so this looks like a person who's actually solving the problem, at least on first glance. All right, yep, he does the same special handling I do. So, yep, finds the middle. And then go the extra one. Yep, with you. No, this is slick. I like this. This is a really cool reverse. And then yep, and then he goes through it and checks that the values are equal to the ones on the list. Yeah, I like this answer. This guy should get all the votes. These solutions are garbage. I have not voted on solutions yet on here, so I'm gonna try. Maybe can I downvote somebody? No, I'd love to vote this guy for not actually solving the problem. This This is the first one I think that like actually solved the problem. That's these top ranking ones. Let's see if this guy actually solves it. I mean, on first glance, it looks like he's actually doing it. Yeah, as well. All right. Yeah. So I will at least upvote this guy because I strongly feel that those top solutions are total crap because they're not solving the problem. All right, cool, cool, cool. I don't know what I might do next on here. I like the arcade challenges better just because I don't have to get quite so invested, but obviously these are much more interesting. I don't know how they'd be to watch though, because it's obviously a quite long video of me grinding these things out. Especially since I'm better with like numeric stuff, numerical programming, scientific stuff normally. So I don't really use a whole lot of linked lists and stuff like that. The array challenges were the better ones, but I've done them all before I started recording any videos. So I can potentially show you my answers and talk about the way I thought about the problems. But I can't, it wouldn't be like this where you can actually see me solving them, because if you solve it once, even if I like deleted my code and solved it again, having seen it and solved it once would make it a very, very different experience. All right, cool, cool, cool.